at AND gate and the NAND gate. Now let's look at the design first. AND gate and NAND gate. AND gate looks like this. If you have input A, B, it's going to be A, B. The output is going to be A, B. In the NAND gate, the difference in design is there will be a NOT gate attached to it. Like you will see a round shape like this. So if you put input A and B, then you're going to get AB prime. That's the complement of this one. Like you can see the difference. And if you write the truth table, like if you don't know what's complement is, like if you take 0 and take the complement for it, that is 1. And if you take the 1 complement, that is equal to 0. Okay. Now let's look at the truth table for both of them. Truth table for AND gate. If you have A and B, what's going to be the AB? So first, if we take 0, 0, the output is going to be 0. If we input 0 and 1, the output is still going to be 0. And if we input 1 and 0, the output is still going to be 0. And the only case the output will be 1 if both of them are 1. This is the truth table for AND gate. And for the NAND gate, A, B, AB prime, the truth table look like this. If you have input of 0, 0, the output is 1. And if you have input of 0, 1, the output is 1. And if you have input of 1 and 0, the output is still 1. And if you have 1, 1, the output is 0. The only time the output is 0 is when both of A and B are 1. And you can see this whole thing, this column and this column. This column is a complement of this column, right? Because that's what it do. Like NAND gate is basically flip of this AND gate. Like it's like we are attaching a NOT gate at the end. And you know, if you want to draw NAND gate, you can draw in a different, like you can actually create NAND gate with the AND gate and NOT gate as well. I'm going to show you the design. So if you draw this one, so let's say we have an AND gate here, and the input is AB, and the output is going to be A times B. And then if we attach NOT gate to this is a NOT gate, and if you attach this, we are going to get AB prime. And this whole thing, this design is equivalent to a NAND gate. Right? So that's basically the relationship. Now let's look at another thing. I'm going to go ahead and erase everything. So let's say a NAND gate is given. A NAND gate is given. And if you make that one, you can make the NAND gate, like if you have a 2-input NAND gate, you can make it to 1 input by connecting both wires like this. And then you can do 1 input. And let's say we have a 2-input, another one. And in this one, we are putting A, B. And this is a NAND gate. What's going to be the final outcome for this one? For this one, we know that the final outcome is AB prime. What's going to be the final outcome for this one? This one, the final outcome is going to be AA prime. Why AA prime? Because this, if we input A, here we are going to have an A, and here we are going to have an A. So finally, and also this is a NAND gate, so the finally it's going to be complemented, so we are going to have AA prime. But at the end, it's going to be A prime, because in Boolean algebra, like A times A is equal to A. We will learn this later. I will do this in my next videos. So A times A is A, 0 times 0 is 0, 1 times 1 is 1. So you have to know these things. So instead of a times a prime, we can put a prime. Okay, so you can see this is almost like a NOT gate. This is a NOT gate, you can say. Another way, like if you have a NAND gate and if they ask you to create a NOT gate using that, you can create it by connecting both wires like this. So here also in NOT gate, if you put input a, the output is a prime. That's what we get here as well. So the NAND gate, actually you can make it a NOT gate by attaching the two wires together. And that's it for this video, guys. Thanks for watching, and I'm gonna go ahead and continue more logic gates with my next videos. And don't forget to subscribe my channel. See you guys on my next video.